This is the video for section 9.2 notes, slides 7 through 11. All right, so this is a little bit of a review of differential equations, but then a specific type of thing comes up that maybe we haven't had to do before. All right, so let f be the function with f of 0 equals negative 3, such that for all points x, y on the graph of f prime is 4x times the quantity f of x minus 2. All right, so it's important that we understand, first of all, that f prime of x equals 4x, right? So this is a differential equation, right? This is a derivative, right? Now, first of all, it says find f double prime of 0. All right, so this is actually, well, pretty easy. We're just finding the derivative of this, all right? So if f prime of x is 4x times f of x minus 2, all right, we're going to find the second derivative. Now, first of all, you got to go back and you got to remember this is a product, so we're going to use the product rule. All right, so 4x times the derivative of f of x minus 2. Derivative of f of x is f prime of x minus 0, of course, and then plus f of x minus 2 times the derivative of 4x, which is 4. So this is f double prime of x. Now, f double prime of 0, all right, so that would be f double prime of 0. So now x is 0, so 4 times 0 times f prime of 0 plus f of 0 minus 2 times 4. All right, so now 4 times 0, that's 0, right? But then times f prime of 0. Well, f prime of 0, well, you would actually have to figure that out up here. Now, technically, we don't need it because 4 times 0 times that is 0. But let's just go on the side real quick. What is f prime of 0? So that would be 4 times 0 times f of 0 minus 2, right? So 4 times 0, of course, is 0. But what is f of 0 minus 2? Well, f of 0 is negative 3 minus 2, right? So, of course, this is still 0. So, yes, this is still going to be 0. But then plus, all right, f of 0 minus 2. So what is f of 0? Well, f of 0 is negative 3. So negative 3 minus 2 and then times 4, right? So f prime, double prime of 0 is, well, 0 plus, all right, negative 3 minus 2 is negative 5 times 4 is negative 20, all right? So f double prime of 0 is negative 20. So that's the first part. But now it says, does f have a local maximum or minimum at x equals 0? All right, so we want to go back to unit 4. You were just told to find f double prime, but now you're asking about a local min or local max. All right, so let's remind ourselves. Okay, local max could look like this, right? Derivative goes from positive to negative. Local min could look like this. Derivative goes from negative to positive. All right, but here's the problem. I don't know enough information in order to do a sign analysis of the derivative because I don't have f of x. So now the next thing I need to do is I need to think about, okay, well, what is the second derivative? So remind yourself, the first derivative is 0 right here, but the second derivative is negative, right? It's concave down. All right, here, the first derivative is equal to 0, but the second derivative is positive. So the question is what is f prime of 0? Well, f prime of 0 is 0. We figured that out earlier up here. And f double prime of 0 is equal to negative 20, which is negative, right? So what does that mean? Well, look at the two pictures. The first one had f prime equals 0 and f double prime was less than 0. Therefore, so f of 0 is a local maximum. All right, so this is a little bit of definitely a review of some things in Unit 4. All right, but this is still falling into the category of a differential equation because we were given something involving f prime. All right, so let's keep going with differential equations. All right, so slide 8. All right, so let f be a function with f of 0 equals negative 3, so same thing, such that all points x, y on the graph, so still given the same f prime of x equals 4x times f of x minus 2. All right, so now it says find f of x. All right, so now we're going the other way. So how am I going to find f of x? First thing is a notation thing. F prime of x, remember, is the derivative of f of x with respect to x. So the derivative of f of x with respect to x is 4x times f of x minus 2. Now, here's the thing that people get confused about, all right? I've got x here, and then I've got x here, but here's the thing, okay? Let's let f of x equal y. So if I rewrite this, I have dy dx equals 4x times y minus 2. So now, if I want to find f of x, I'm really finding y, aren't I? And so this looks more like the differential equations that we're used to. So what I want to do is I want to separate the variables. So I want to multiply by dx, and then I want to divide by y minus 2. So dy over y minus 2 equals 4x dx. All right. So now, once I separate the variables, I've got my y's on the left, I've got my x's on the right, so I'm going to integrate. All right, now this is an indefinite integral, right? Because we're not trying to find area under a curve or something. All right, so now, on the left side, technically I would need a u substitution, right? So u equals y minus 2, so du equals dy. So actually, we just have the integral of 1 over u du, right? No extra constants or anything like that. All right. So what is the integral of 1 over u du? It is natural log of the absolute value of u, which is just y minus 2, right? Equals, all right, what's the integral of 4x dx? It would be 4x squared over 2, or 2x squared, and then don't forget about the plus c. All right, now, what do we need to do? Well, we need to use the fact that f of 0 is equal to 3 in order to find c. So f of 0, so that would mean the natural log of the absolute value of negative 3 minus 2 equals 2 times 0 squared plus c. All right, so now let's continue. All right, so the natural log of the absolute value of negative 3 minus 2. Negative 3 minus 2 is negative 5, but the absolute value would just give me natural log of 5 equals 0 plus c. So c is the natural log of 5. All right, so what does that mean? All right, so now I'm going to go up here, and I'm going to say, okay, the natural log of y, remember, y was actually f of x, wasn't it? So the natural log of the absolute value of f of x minus 2 equals 2x squared plus the natural log of 5. All right, so now, what did the original problem tell us to do? Right, remember, the original problem said to find f of x. So I actually have to do the algebra here, right? I can't just leave this, even though it is the equation that has that true, but it specifically says find f of x, so I have to do the algebra. All right, so first of all, how do I do the algebra? Well, I got to get rid of the natural log, so I need to exponentiate both sides. So I'm going to make each side a power of e. So that means those cancel, so I'm left with the absolute value of f of x minus 2 equals e to the 2x squared plus the natural log of 5. Remember, the whole side, 2x squared plus the natural log of 5, is in the power of e. All right. Now, I've got two things that I need to do. Number one, I got to get rid of the absolute value. Then I got to get rid of the 2. All right, so the 2 is easy, but the absolute value has to go first. How do I get rid of an absolute value? So let me ask you a question. Up here on the side, if I have the absolute value of x equals 2, well, think about it. Right? That means x could be 2, or x could be negative 2. So really, how do I get rid of the absolute value? I just put a plus or minus on the other side. That's really it. So if I have the absolute value of f of x minus 2, I have f of x minus 2 could equal the positive or negative e to the 2x squared plus natural log of 5. Right? So that's pretty easy. So then we're going to add 2. So f of x equals 2 plus or minus e to the 2x squared plus the natural log of 5. But remember, this is 2 answers. So now we need to figure out, is it 2 plus this thing, or is it 2 minus this thing? Well, let's simplify a little bit first. All right, so e to the 2x squared plus the natural log of 5. Okay, I want to go up here on the side once again to think about. All right, so if I go on the side, if I have like x to the 5th, right? Remember, that's really just x squared times x cubed. But remember, 5 is 2 plus 3, isn't it? So what I'm saying is if I have e to the 2x squared plus the natural log of 5, that's actually e to the 2x squared times e to the natural log of 5, isn't it? Right? Because 2x squared plus the natural log of 5 can be split up just like we did up there. All right, and so now, why did I do that? Well, because e to the natural log of 5, those reduce, and it's just 5. And so what I really have then is f of x is equal to 2 plus or minus 5 times e to the 2x squared. All right, so now let's finish. So if x is 0, then what? E to the 0 is 1. So 2 plus 5 or 2 minus 5. So remember, f of 0 was -3. Therefore, f of x is 2 minus 5e to the 2x squared, right? So that is our answer, right? Now, that is a bunch of old stuff, right? Okay, that's just a nice little review of some differential equations, which is very important, all right? But now, when does it get different? All right, so let's go on to the next one. All right, slide 9. Suppose an object moves along the x-axis so that its acceleration at any time t greater than or equal to 0 is a of t equals the natural log of t squared plus 1. If v of 2 is 5, find v of 6. All right, so first of all, okay, we're given a of t, but we're asked about v, right? So this is a differential equation. So first thing to remember, a of t is actually the derivative of velocity, right? So first thing is notational. A of t is dv of t dt, right? So now, that is the natural log of t squared plus 1. All right, so now I want to solve for v, so I'm going to multiply by dt. So dv of t equals the natural log of t squared plus 1 dt. All right, and so now we say, okay, well, I want to solve for v, so I'm going to integrate both sides. All right, so now if I integrate, on the left I would get v of t. That's easy enough. But now on the right, integral of natural log of t squared plus 1. All right, so how do we do this? Well, we would say, okay, well, that means u equals t squared plus 1. So du would be 2t dt. So now, here's the thing. There is no t on the outside. So what does that mean? You cannot use this u substitution, and you actually cannot carry out this integral, all right, by hand, all right? So when I say by hand, you'd say, well, wait a minute. If we're going to type this into our calculator, right, I have to have limits, right, like we did in Unit 8. So what we want to do is we want to make this into a definite integral, right? Remember, if I integrate this, I'm going to get velocity, right? So I'm going to integrate acceleration, right, a of t dt, from 2 to 6. Why 2 to 6? Because those are the two values of time that I'm referencing. So if I integrate a, what do I get? I get v. I would plug 6 in, so v of 6, minus, I would plug 2 in, v of 2. All right? So now, let's think. I know that v of 2 is 5, and I want to find v of 6. So how do I solve for v of 6? I'm going to add v of 2 to the other side. So v of 6 is the integral from 2 to 6 of a of t dt, and then plus v of 2. All right? So now, let's calculate. All right, so v of 6 is, all right, so we want to do that calculation. All right, so we need to pull up our calculator. All right, so let's pull up our calculator. All right, so remember, I want to do math 9. All right, so the integral from 2 to 6 of a of t. So a of t is the natural log of t squared plus 1, so x squared plus 1. All right, close parentheses on the natural log, comma, x, with respect to x, comma, 2, comma, 6. All right, so that's my value of the integral. So I get 11.044. So 11.044, and then plus, what is v of 2? Well, remember, v of 2, if you look up here, is 5. So v of 2 is 5, and so v of 6 is approximately 16.044. All right? So this is where it's a differential equation that starts off looking like maybe a non-calculator question, but this is actually a great example of a calculator differential equation. All right, so now let's go on to slide number 10. All right, so slide 10. All right, an object moves along the x-axis so that its velocity at t greater than or equal to 0 is v of t equals sine of t cubed. At t equals 0, the position is 4. Find the position at t equals 2. So this is almost the exact same thing. We recognize that v is sine of t cubed, but I want position, so I would have to integrate v. Now, if I think just the integral of sine of t cubed, I would need a u substitution of t cubed, which doesn't work because I don't have a t squared on the outside. So what do? We are going to integrate the v of t function with respect to t from 0 to 2. All right, so from 0 to 2. So what is that going to find for me? that's going to find the position, and I'm going to use x of 2 minus x of 0, right? So now what do I want to find? I want to find x of 2. So x of 2 is going to be the integral from 0 to 2 of the v, which is sine of t cubed, dt, and then plus I would add the x of 0 to that side. All right, so now this is just a calculation. All right, so once again, let's get out our calculator. All right, so now I'm going to say math 9. All right, and I'm going to take sine of t cubed. All right, close parentheses on the sine, comma x with respect to x, comma 0, comma 2. All right, and so now I calculate my integral. Make sure that you are in radians. All right, and then I hit enter, and I get 0.452. So I'm going to get 0.452. All right, so approximately 0.452, and then plus the value of x of 0. So x of 0 is 4. So I get the position at t equals 2 is 4.452. So now, let's make sure we understand what this integral is actually doing. If I integrate velocity from 0 to 2, what do I get? Well, x of 2 minus x of 0 would actually represent the change in position. Right, that would represent the change in position from 0 to 2. So if I know the position is 4 and it changed by 0.452, now my position is 4.452. All right, if I go back to slide 9, same thing is true here. What does this represent? The integral from 2 to 6 of a. That represents the change in velocity from 2 to 6, right? And so I started with 5. I changed by 11.044. So now I'm at 16.044. All right. So the integral of a is going to represent the change in velocity from 2 to 6. All right. So now that is important for understanding example number 5. All right. F is a function defined on the closed interval 0 to 4, such that f prime of x is x plus 1 to the sine x minus 2. For what value of x does f attain its minimum value? All right, so this is really kind of a difficult question. Okay, so what we want to do is we want to think about f prime. So we want to think about the sign analysis of f prime, but this is not one that you could possibly do by hand. This is a calculator question. So pull out your calculator. All right, so I want a graph, right? Because I'm going to do the sign analysis. So x plus 1, and then to the power sine x. I'm going to close parentheses on the sign, right? And then I'm going to hit minus 2. All right, now I want to right away go to my window, and I want to make the x minimum 0 and the x maximum 4 because that's the given domain. All right, now y minimum and maximum, well, you may need to look at the graph before you adjust those. All right, so I hit graph, and it's really kind of difficult to see, so I'm going to make my y minimum like -2 and my y maximum +2, and then I'll be able to see the picture a little bit more clearly. All right, so now what you want to do is you want to give yourself a drawing of this, right? Or I'm just going to do a little screenshot of it. All right, so now I screenshot this drawing. All right, and okay, so now what we want to do is we want to make sure that we understand exactly what's happening here. All right, this is a graph of f prime. So what does that mean? Well, in this first section, I'm going to say from 0 to a, what's going on? F prime is below the x-axis, so f prime is negative, right? So we're doing a sign analysis, right? F prime is negative. All right, between a and let's say b, and we can find those values, but I'm just referring to them as a and b right now. F prime is positive, right? It's above the x-axis. And then from b to 4, f prime is below the x-axis, so that means it's negative. So what does that mean? All right, so let's think. I'm starting at some value, right? So let's say f of 0 is some value, right? We don't know what that is. Okay, now, what would f of a be? Well, let's think. If the derivative is negative, that means from 0, if we think from 0, I'm going downwards, right? The derivative is negative. So what can you say about f of a? F of a is less than f of 0. Everyone agree with that? All right, now, what's going on at a? Well, the derivative changes from negative to positive. So what must be happening at f of a? We must have a local minimum, right? So make sure you write yourself a little note. Local minimum. All right, next, what's going on from a to b? F of b, well, let's think. The derivative is positive, so from a to b, we must have gone upwards, right? And so that means f of b is greater than f of a. Yes? All right, so now what's going on at b? Well, the derivative changes from positive to negative, so we must have a local max. So write yourself a little note. Local maximum at b. All right. Now, from b to 4, what's going on? Well, what's happening is that the derivative is negative, so we must be going downwards until the end of our domain. So that means f of 4 must be less than f of b. Everyone agree? All right, so now, if we look at this picture, here's the value at 0, here's the value over at 4. It says, when does f attain its minimum? Well, it could be at a or it could be at 4. I don't know which one. So how do I compare f of a and f of 4. So what we're going to do is we're going to integrate the f prime function with respect to x from a to 4. And what is that going to equal? That's going to equal f, right? Remember, if I integrate f prime, I get f of 4 minus f of a, right? So we want to find the value of that integral. All right, so now let's go back to the calculator. What do I need to know? Well, I need to know a. All right, so how do I find a? So on my graph, I'm going to do second trace, and I'm going to use the 0 function. All right, so it says left bound, so I'm going to go all the way over here, right? And you could just type in a number, but all right, so over here, I'm on the left of that 0, enter. Then I need to go over, and I could just type in a number, but all right, now I'm on the right of that 0. All right, guess there's only one 0 on the interval that I've selected, so just hit enter. All right, and so I get 1.142. 1.142. All right, so I'm going to go back over here and I'm going to say, okay, a is approximately 1.142. So when I do this calculation, I'm going to integrate from 1.142 to 4. All right, so now back to my calculator. All right, so now get out of this screen, go to your normal calculate screen, and I'm going to type in math 9. And I'm going to type in the function. So what is the function? X plus 1 to the sine x minus 2. Or remember, this is just in y1. So you could just go vars, y vars function, y1. Okay, so that's the function, comma, x, comma, 1.142, comma, 4. All right, so now that is the value of our integral. So we get negative 0.859. Okay, so negative 0.860. All right, so negative 0.860, right? That's the value of the integral is equal to f of 4 minus f of a. Now, let's think for a second. The value of this integral is negative. So what does that mean? That the change in f, so write this down, change in f from a to 4 is less than 0. What does that mean? The change is negative. That means from f of a to f of 4, I must have gone downwards. Correct? So if from a to 4 I've gone downwards, then what does that mean? That means that f of 4 is the minimum, right? But let's say it a little bit more clearly. F of 4 minus f of a is equal to negative 0.860. In other words, f of 4 minus f of a is negative, right? Less than 0. So that means that f of 4, if I just add f of a over, is less than f of a. Therefore, the minimum occurs at x equals 4. All right? So obviously we'll talk about it a little bit more in class, but these are some great calculator questions.